We have a couple of different types of tools. So quite importantly, at the top we have tools for users, which help them to compose their multiscale applications and to also use the different patterns. And then in combination with that, we have a couple of tools that optimize the applications for performance. So to make sure that they either run very quickly on large-scale computers, or they run very energy efficiently. And then finally, there are tools that are maintained by the administrators, not by the users. And those are deployed or installed on the supercomputers themselves. And they allow us to flexibly run these multiscale applications. Multiscale computing patterns are, as the name implies, a set of three patterns which you can apply to multiscale applications to combine different single-scale submodels in different ways. The idea of the patterns is that you can have a diverse set of applications mapped to one of these three patterns or a combination of them. And in doing so, it allows you to map these applications very efficiently to large-scale resources. So the essential point of multiscale computing patterns is that instead of manually transporting every application to exascale infrastructures, that instead we can focus on porting the patterns, and then we fit the applications within the patterns. The last thing is that the patterns have been designed in such a way that they capture the vast majority of large-scale multiscale applications that we can think of. The extreme scaling computing pattern. This is the alternating version. In the extreme scaling computing pattern, we have a primary model, which is represented by the big dot. The primary model runs, and at some point it requires the inputs from auxiliary models. These are started. The primary model then communicates information to the auxiliary models. The auxiliary models run, and upon their completion they pass information back to the primary model. The concurrent version is slightly different. Here the primary model also runs, but the auxiliary models run at the same time, and both models exchange information between each other. Again, the primary model has a higher computational cost than the auxiliary models. The heterogeneous multiscale computing pattern. In this pattern we have a macroscale model, which is represented by the dot at the top, the gray dot. In addition, we have a HMC manager, which manages microscale information and passes that back to the macroscale model. In some cases, this microscale information is readily available in the database of the manager and it passes it back. However, in other cases, the data is not readily available or not sufficiently accurate, and HMC manager will then trigger the execution of a microscale model, which is represented by the small dot. Over the course of a simulation, the HMC manager will receive many requests from the microscale model, and as a result, it may return many values and also, for a subset of those requests, perform microscale simulations. The replica computing pattern. In this pattern, we start an ensemble of submodels, which are represented here by the small green dots at the bottom. In this ensemble, there are multiple instances of the same submodel that are being run either concurrently or one after another, but as a set. After these models have completed, they pass information to the other submodels within the multiscale application. This second set of submodels is also run as an ensemble with multiple instances. After this second set is finished, the information is then collected and to be used for further analysis.